Hello, this is Nikki Jackson, one of the math instructors here at Southwest Tennessee Community College. And what this video is engulfing is dealing with particular examples taken from Math 1530 Introductory Statistics from Homework 2.1. As you can see right now, there's a particular problem. And you may have to pause the video periodically so you can actually follow along with this. Also, make sure that you have a TI-83 or TI-84 calculator available. For this particular sample, we're looking at this graph right here. So you may notice that your y-axis is dealing with the number of, what does that say? Professors. And then your x-axis is dealing with the number of courses taught. Hopefully you can actually see the numbers. So I'm going to have to zoom in and move it around so you can have a better view of that. So there you have it. So these numbers right here, so you have 3, 17, 23, and 16. So I'm going to slide that over. So notice how I fill in the blank for this particular table. Also on the side in the blue, hopefully you can see those colors. I'm saying that you actually have to use the calculator to figure out what these problems are or how to solve them. Now you may do this by hand, but because this is a 5-week course, it might be wise just to use your calculator, and it's also a lot simpler. Those of you who are not taking a 5-week course or doing this full semester, still the calculator is like a little bit easier to use. So notice how I said use the calculator. In red, you also see that I've already filled in the blanks. But now let's figure out how I use the calculator to do that. So the first thing I want you to do is actually use your calculator and cut it on. So the on key is down here in the lower left hand corner. Because this is a statistics course, next I want you to hit the stat key, hit enter for edit, and I want you to clear out your L1 and L2. Those represent your actual lists. So I'm going to clear out my list, and hopefully you can actually see this yellow fingernail polish, so you can see me going in and out, making it a little bit easier to view. So for L1, we're going to put in 1, 2, 3, and 4. So 1, enter, 2, enter, on and on. Make sure you hit enter each time you lock it in. Use your right arrow key to put in the other numbers for L. So it'll be 3, 17, 23, 16. Now notice right here that you actually are using an X value and an F value. F represents frequency. You can see that word right here, meaning that it is not another value. It's just telling you how often your X occurs. So if your X value is 1, it occurs 3 times. X value is 2, it occurs 7 times. And all that data itself is coming from the table. So to figure out how we got the answer of 2.9 and 0.9, you're going to hit your stat key again, use your right arrow key to calculate, hit enter for one variable stats. Now some people might have an older calculator, so you won't see all of this right here. You simply just hit enter. But if you have a newer calculator, like I do, make sure you have L1, then you have second, then the number 2, where L2 pops up. For your mean, that is represented by X bar, it's asking you to round to 1 decimal place, so that 8 is going to turn into a 9. And then you're looking for your standard deviation. Standard deviation is going to be represented by SX. So that 7 is going to make that 8 and 9. So as I stated earlier, if you have an older calculator, you'll still follow the same procedures, except be careful. You'll actually have to put in something completely different. You'll have to put in one variable stats, then second the number 1, comma, then the second and number 2. You may actually have to use another YouTube video to actually go into details with that, but this is only for the older calculator. Your next example is dealing with number 2. So again, my apologies, got to zoom in and out so everybody can see it. So it's asking you to find the range, and by definition, your range is the difference between your largest and smallest values. So again, I'm going to do a lot of in and out with the zooming. Notice how your largest number is 100, your smallest number is 70. But you're going to actually look at your dots. So your largest dot is at 98, and your smallest dot is at 73. So remember, the definition of range is the difference between your largest and your smallest. So we're looking at the dots, not what's actually listed for your range. So 98 minus 73 give us 25. But before we move on to number 3, let's do a quick example of what we're going to use our calculators for. So this is a good time for you to pause the video to write these symbols down. And what that means is that you're going to use this over and over again for modules 2, 3, 4, and 5. But the main symbols you're going to be using are your standard deviation, variance, and your mean. Your mean would be represented by your x bar. Your standard deviation, there's going to be 2 possible outcomes for that. You're going to have your SX, then you have your OX. Your SX is going to be used only when it's asking for a sample. When you're using your OX, it's asking for a population. So you have to make sure that you read your problems carefully when it will specify whether it's a sample or population. Notice I'm using a calculator from the previous example used, what your SX and your OX will actually look like. Though they're very close as far as rounding, they're slightly different. Remember by definition in Module 1 that the sample was a subset of the population. Variance is also not computed in your calculator. You actually have to write all the digits for your S of x, then squared, if you're looking for a sample variance. You have to do the same thing for your O of x if you're looking for the population variance. So my apologies for the slight pause. Again, here's an example. We're only focusing on number 3 at the moment. So let's zoom in so you can actually read what it's saying. Now off to the side, I said that the O represents your population and the S represents the sample. What it's asking is, given a data set, how do you know whether to use your population or your sample? Well, the given answer is B. When given a data set, one would have to determine if it's representing the population or if it's a sample taken from the population. If the data is a population, then O is calculated. If the data is sample, then S is calculated. If you read each one of these other answer choices carefully, you can then use process of elimination. Now we're moving on to a more complex example. Have you ever wondered how your GPA is calculated, especially those of us who are almost ready to graduate, or we're trying to make sure that we graduate with honors or maintain a certain scholarship? Well, this is how you do it. Your GPA is your grade point average. It is determined by your number of credits times the number of classes and then times your points. So I'm going to take a brief moment to zoom in so you can actually see the point values for each grade. So our A is worth 4, a B is worth 3, a C is worth 2, and a D is worth 1. You can automatically assume that an F is some 0. For across the top, using the information that's given, I actually multiply each thing. So notice this peak mark right here is focusing on the B. A B is worth 3 points. So you earned a B in 3 classes, in which each class is worth 2 credits. Therefore, you have 3 times 2 times 3. Or I said that backwards. 3 times 3 times 2. My apologies. Your A is worth 4 points. So that's your 4 times 1 times 3. Notice where I'm getting the numbers from. For your D is worth 1 point. 1 times 4 times 1. And the same as goes for your C. 2 times 1 times 3. So that's just your numerator. Notice also for your denominator, this is just dealing with your number of credits. So with your B, you took 3 classes, and each class is worth 2 credits. You had an A in one class, and that one class is worth 3 credits. You got a C in one class, that C was in one class that was worth 4 credits. And then you had a C, and I got that all backwards. So I made a mistake here. So you're going to hear quite some noise now. And the reason why you're going to hear the noise is so I can actually make the corrections. So you probably didn't see what I did. But the D goes with this. The C goes with that. I'm only looking at the credit hours right there. So now, let's use our calculator. I'm going to do the numerator first. So I'm going to have 3 times 3 times 2 plus 4 times 1 times 3 plus 1 times 1 times 4 plus 2 times 1 times 3. So we have a total of 40. For your number of credits, which is your denominator, that would be 3 times 2 plus 1 times 3 plus 1 times 4 plus 1 times 3. So now I'm going to have 40 divided by 16, and that's where we got the 2.5 from. Your next example, number 5. Make sure you have your calculator handy, because you will need it. This is focusing on a stem leaf plot. Now the reason why it's called a stem leaf plot is because you have your tens value places on the left, and then you have your ones on here on the right. So if I zoom in, notice how your smallest number is going to be 3. Your next to the smallest number is 8. My largest number must be 55, and the next to the largest number is 49. So again, the numbers are split. Notice how I have written out. You have to use your calculator. So what we're doing right here is trying to find the mean, median, and mode. You may recall that your mean, median, mode also calls your measures of central tendency. Now the reason why they're called measures of central tendency is because those are the most commonly used ways to compare stuff. Your mean is also known as your average. Your median is the number in the middle once you put your numbers in order from least to greatest. And your mode is the number that appears the most. So let's see how to put these in the calculator. So once again, I'm going to hit my stat key, hit enter for edit. Because from the previous example, I'm going to use my arrow keys, go all the way up to L2, then hit clear. Never ever ever hit delete. Never. Because if you delete it, you're literally deleting the whole column. Now using my arrow keys, I'm going to go up to L1 and hit clear. Be mindful that clear is directly right here. So hopefully again you can see my yellow handwriting, my finger polish. So all of these numbers are going to go to L1. So 3 is the first number because you only have 3, then 8. Then the next one is 11, then 12, 15, and 16. And on and on and on until we get all the numbers in. So it might take a minute to actually put all the numbers in. So for example, like I just made that mistake, I can just hit clear and then type the number again. Make sure you hit enter to lock it in. You also notice that you had a 28 3 times. And you had a 30 that was 3 times. You can assume, and again I made a mistake, I'm happy I'm doing that so you won't be doing it as fast and make the same mistakes in one minute. It's very important to make sure that you hit the enter key. So once I have it in, voila, I have all my numbers. Go back to the stat key. Use your down arrow key for sort for ascending. That's that sort A. That means you're going to put the numbers in order from least to greatest. Since we used L1 for our list, I'm going to hit the second key, then the number 1. Hit enter. Nothing magical happened. But if I hit the stat key again, then hit enter for edit. Notice how your numbers are in order from least to greatest, even though we've already done that. But it's a good idea to make sure you do it at all times in case you make a mistake. We're going to hit the stat key again, use your right arrow key, go to calculate from one variable stats, hit enter. Because we only used one list, that was L1, if your calculator looks like this, hit clear for L2. Then hit enter, then hit enter again. Those of you who have an older calculator, you just see one variable stats and hit enter. So looking at X bar, and then we round it to the nearest 10. That 8 is going to make that 7 and 8. Therefore, our answer for our mean is 29.8. Using your down arrow key till you cannot go down anymore, your medium is 30. Then your mode, which you can look at your graph and see. And what I mean by your graph is your standard leaf plot. Notice how you have this 8 that is repeating more than once, along with the 0 more than once. Therefore, your mode would be 2 modes, 28 and 30. But the more complex part is the interpretation. Be mindful that your mean, median, and mode are all measures of central tendency. So for this part, the mean represents the center of the data. That is true because it's very close to your actual median. Your median was 30, which actually represents the center of the data. But now we have our mode, which we previously discussed. The mode, because those numbers appeared more than once, were 28 and 30. And they also appeared the most. The mode does represent a typical entry of the data. Because remember, you saw your 28 3 times and your 30 3 times. But make sure you read each of these answers carefully, because sometimes they don't always apply. You know that they're not the smallest and the greatest of them, because your smallest is 3 and your largest is 55. Here's another example. Once again, we're going to use our calculator. So let me zoom in so you can see it. Here goes your data set. This one is asking you to find the range, population, population variance, and population standard deviation, along with your mean. So let's use our calculator. And I'm going to be zooming in and out so everybody can have a good view of what to do. And if by chance you ever get confused, please feel free to Google other videos to make sure that it's helpful to use it. Videos are also posted in stcc.mylabs+ to help you. So, stat key, you probably can't see it right now. Nope, that made it worse. So let me ease it over at the glare. There we go. Stat key, hit enter for edit. Use your up arrow key, clear, then enter for your L1. You just cleared it out. The numbers now are as follows. You have 2, 7, 15, 4, 12, 9, 11, 7, 2, and 8. And again, my apologies if you can't see this, but I'm working with very poor lighting and I'm working from home. And this is not a professional studio. But thank you for your patience in watching and tuning in. So now that I got the numbers in, go to Stat, go to Calculate, hit Enter for one variable stats. Remember, if you have an older calculator, you simply just hit enter because this is all that you see. If you have a calculator that looks similar to mine, make sure that L1 is listed on your list and your frequency list is totally blank. Now I'm going to go to calculate, hit enter. Voila, you have everything that you need. But let's go back to what this actually asking for. So notice off here I said use your calculator. Then I have these symbols written out. So by definition, your range is your largest number minus your smallest number. So that's 15 minus 2. That gave you 13. With my calculator, you're looking for your X bar. So X bar is 7.7. For your variance, you're going to have to write all of those numbers down. And once you write all of those numbers down, you'll have to square it. That's how you find your variation. And then for the standard deviation, it's already given to you. That 5 is going to make that 0 or 1, therefore you have 4.1. So you may notice that the variance is your standard deviation squared. So sometimes you might have to work a little bit backwards to figure out what's going on. So now I'm going to show you how to find the variance. So I'm going to type in my standard deviation in every single digit. Do not round on the front end, round on the back end because it will mark it wrong as far as the computer. Then I made a mistake myself. I put my decimal in the wrong spot. So let me try that again. Now voila, got the correct answer. So I'm human, I make mistakes all the time, so please forgive me. Please, 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 please. So make sure that you have your calculator nice and handy. Your next one, you're dealing with a graph. This is relevant to skewness. Now what skewness is the sudden change of direction. So notice how your graph is completely low on the left hand side. So if I wanted to make this a curve, it will look something like this. Because this curve is low on the left hand side, the shape distribution is skewed left. So for more information about skewness, here are some examples. Notice how you have something that's called symmetric. So if I was a better artist, FYI, I'm not a good artist. If I was to draw that like a perfect heel, and the reason why it's called a bell curve, think about a cowbell or the Christmas bell that you see in Salvation Army. If this was drawn correctly, it would be perfectly symmetric. So if I folded it in half, I would have the exact same thing on both the left and the right. But notice on your measures of central tendency. The reason why they're called central tendency, notice how in the middle you have your mode, medium, and mean. Remember earlier how those numbers were very close together? Here's a visual representation of that. But next you have skewed left. Notice how your curve had a sudden change in direction. That all of a sudden it was curved on the right hand side, but it's skewed left because it's completely low. You still have your mean, median, mode all close together, but your mode is further to the right because that's the number that appears the most. Your median will always be in the middle because you're a median number. Then you have your average, which is where you add them all up and divide. The opposite of skewed left would be skewed right. Notice how there's a sudden change in direction, and it's low on the right hand side. In this example, for this case, the mode is further to the left, your median is still in the middle, and your mean is still going to be your average. In regards to mean, median, and mode, let's do another quick example. Oh, I forgot. I'm sorry. I forgot. Skewness also applies to bar graphs. So this is considered uniform if all of these were the exact same height. Don't forget, I can't draw. So yeah, uniform is when they will be all the same height. Mean, median, mode is very rare that they will actually be all the same numbers, but it is possible. That will also be considered symmetric. The bar graph for uniform is only where it's possible. So here's another example of mean, median, and mode. So So let me zoom in so you can actually see the numbers. Because right underneath that pink line, if you can see it. So we're going to use our calculator for this one. Now, because of time, notice how you already have your answers provided for you. And don't forget, the reason why they are going to represent the center is because they are measures of central tendency. Also notice that your numbers, 47, 45, and 45, are numbers that are listed. So 45 is right here. But 47, since they're so close to one another, and 47 is between 45 and 48, that's why this is considered a mean, even though it's not an actual value. But let's use our calculator for actual proof. So once again, we're going to hit clear on our calculator. Go to stat, hit enter for edit. To clear your list out, go all the way up to L1 and hit clear and enter. And these are your numbers as follows. Again, you might have to actually pause your video every now and then so you can write the numbers down, just in case you're not able to keep up with me, because I am going kind of fast. But the numbers that I just entered are right here. So once I get that last number in, I'm going to hit stat, use your right arrow key, go to calculate, hit enter. Remember, just one variable stats if you have an older calculator, and hit enter. With a newer calculator that looks like this, make sure your frequency list is clear, go down to calculate, and voila, we have our answers. So your mean, which is represented by X bar, is 47.3. Your median, which is your middle number, notice how I'm using the down arrow key so I can't go down anymore. That's the number that's in the middle when you put in the order from least to greatest. And then you have your mode. which is 45. Now the calculator will not compute mode. That's just an assumption that you know. Notice how you see 45 is the number that appears more than once in this case. The mode also represents the center of the data. Going back to an example dealing with skewed left and skewed right. Here's a box whisker plot. Now the reason why it's called a box whisker plot is because you see a box, and the whiskers are on the left side and the right hand side. Notice how I wrote out where in this graph does it appear to be stretched. In other words, what's the longer part? Hopefully you were able to recognize that the longer part is right here on the right hand side, therefore it is skewed right. If it was on the left hand side, it would be skewed left. And if they seem like they were symmetric, it would be symmetric. But your answer is skewed right. Here's another example dealing with your calculator. Now for the time purposes, I'm not going to put the numbers in, but you should know that you're going to put all of these under L1. So your data, enter into L1. Once you put all your numbers in, you will hit your stat key, then calculate, then one variable stat, then hit enter again, and you use your down arrow key till you can't go down anymore, and you'll see Q1, Q2, and Q3. Q2 is the same as your median. To do a box whisker plot, now you will hit second, y equal. Notice how you see your plots. So let me show you that again. Second, y equal. So you do it. Second, y equal. Hit enter. Notice how your graph says it is off, because I know it's off because it's dark. So you're going to hit enter for on. Use your down arrow key, then your right arrow key to find the second box whisker plot. Hit enter. Notice how everything automatically changes for you. Once you see this, go to zoom and go to zoom stat. And then the graph should automatically appear. So let me show you that again. When it stops scrapping. So you don't have to do what I'm doing. So second, y equals, now you do. Enter. Make sure your graph is on. Use your down arrow key and right arrow key till you get to the second box whisker. Notice how you got a scatter plot, a line graph, a bar graph, a box whisker with dots, and then the dot whiskers. Once you hit enter, that appears. Hit the zoom key, then go down to zoom stat. And voila, you have the graph. In regards to graph, here's another one. This particular one is asking you, how could you interpret or determine the measure of central tendency that best represents the graph? Now remember, central tendencies are your mean, median, and mode. If this is all that I just have bar graphs. I don't have exact values. So there is no exact or raw data, so there are no precise numbers available. But I can see something. I see my lowest bar is blue, which represents every 1 to 3 years. And I also see that my highest bar is green, which represents every 6 to 10 years. Now going back to process elimination. The correct answer is E. The mode is the best representation. The data are at the nominal level of measurement. Well, remember in Module 1, nominal means that it's only dealing with labels. And the reason why we know it's labels, we don't have any numbers. It's just telling us what it means. Also, if I read each one of these carefully, make sure that you notice the words uniform, symmetric, skewed right, skewed left, and uniform again. So I'm looking at these words right here. This is dealing with context clues. Well, looking at the graph, we know it's not skewed left, right, or symmetric because there's no perfect curve. Therefore, the only one that was left would have been E. So make sure that you have your definitions available to you when you're actually doing this from Module 1. You may recall that for Module 1, we did not do any of the actual things. That's one that you have to do independently because it was strictly dealing with reading, comprehension, and vocabulary. No computations were actually used. Well, except dealing with the frequency type. That was one that we actually had to do. So now we're moving on to your next example. And here we go. So this one, once again, is asking you to use your calculator, meaning that you have to put all these numbers in the calculator in some form or fashion. So if that is the case, we're going to let your heights be your x values. They go under L1, and your ages be your y values, which are going to go under L2. So we're going to cut our calculator on. So I'm going to zoom in just a little bit so you can see it. So once it's on, hit Stat, hit Enter for Edit. And I'm sorry about this glare. Let me see if I can move it. Nope, that made it worse. It's not working. It's not working. Yeah, that's about as good as it's going to get, y'all. And it's still a bad glare. But you actually see the numbers a little bit better now. So once you see the numbers, your X values go under L1, your Y values go under L2. So I stopped at 30, so now I got the 29, 37, 35, and 36. So this might be a good time for you to actually pause and make sure that you have all your numbers in. Because I made a mistake myself that I see. So it does take some time. And again, make sure you pause your video so you can see everything. Now be mindful. At any given time, you can go back and watch these videos because they are posted in pause. PAWS in this case. And other additional videos are also available in STCC.MyLabs Plus for your actual assignments are provided. So I found my mistake. That's why you don't hear me. So I got my numbers in. I'm going to go to Stat, Calculate, hit Enter for one variable stats. Now, here's the thing. You're looking for your CV for heights, and you're looking for your CV for ages. Now, what the CV is a coefficient of variation. You want to see how varied they are, how far off they are together. So here's your formula. I'm going to hit Enter for one variable stats. Now here I go to the calculator. So I'm looking for my standard deviation, which is 3.178. I said 8. So 3.18. That 5 is going to make that 7 8. Divided by 75.5 times 100. So I'm going to do that. So I hit clear, then 3.18 divided by 75.5. Might need a decimal maker. Times 100. So it's asking to round to one decimal place. So that 1 doesn't do anything to that 2, so therefore we got the 4.2. But now we got to find the CV for our ages. So go back to Stat, go back to Calculate, one variable stats. But remember, your ages were under L2. So I'm going to hit the second key and the number 2. Hit Enter. The older calculators, you'll do the same thing too. You'll see one variable stats, then hit your second key, which is right here, and the number 2. You're going to hit Enter again. For your OX, you're going to do 4.89, because that 7 is going to make that 89. Divided by 28.67. I'm just going to keep them on the same hundreds place. You don't have to round. I just did that because I really didn't want to write all those numbers. But notice how I'm consistent with my rounding. So now I have 4.89 divided by 28.67 times 100s. And voila. We might be a slight bit off right here because if we were to round correctly, that would have been 17.1. But I'm just going to keep it as a 0 for preciseness because I did this on the computer to miss if I was wrong. But I am reviewing it while you're doing it. So there you see for I'm not rounding in this case. So if you're looking at both your CVs, notice how your ages is the higher one. Therefore, ages are more variable than heights. Therefore, your answer is C. Now we have your last example. Notice how once again it's asking you to use your calculator. So all your values go under L1. And remember, your mean is going to be your X bar. Your median is MED. Also, to find this, don't forget to sort A for this one. This is how you find it. Now, the reason why I was doing it, because look how many numbers those are. That's quite a bit. So I will assume with the previous examples that we did, you'll be able to do this on your own. So blah, blah, she's from blah. But one of the ones that I know you might have problems with is going to be with the skewness. So notice how I'm turning my paper. The correct answer was C. If I wanted to make this a bell curve, notice how it's low on the right. Since it's low on the right, it is skewed right. So I'm turning my paper again. Notice how your answer choice, the distribution is skewed right. So ladies and gentlemen, that concludes this video for your homework examples for 2.1 for Math 1530. Please make sure that you actually review all of your lessons that are available on stcc.myLabs+. And I look forward to seeing y'all again, or hearing from you again, or you watching me again in next future videos. Thank you.